Hello everyone, welcome to Mind Maps. In this video lecture, we are discussing xanthene dyes. Okay, this is the second part of the dyes video. I hope you find it a bit less boring because these reactions are basically something you need to memorize, but it would be better if you write and practice them and how things go around. That's the only way forward, right? So we should not be scared of topics that feel like a lot of rote learning, but still I like to put some sense into these topics. Let's start. So xanthene, okay, what is a xanthene? It's a dibenzylpyran. Okay, there are two benzene rings and this is a pyron ring. Okay, so that's why we call it dibenzylpyran. Okay, now what you can do is you introduce oxochromes and chromophores. Okay, what are they? Chromophores are groups that are responsible for imparting color, and oxochrome, they intensify the color, right? Let's start with the first synthesis, that is Pyronine G. Okay, so we have meta dimethyl amino phenol. Okay, meta dimethyl amino phenol. So 1 to 3rd position. Okay, meta position we have dimethyl amino phenol. Okay, we have 2 moles of this. The first one is this one and the second one is right here. Why? Because we need these 2 benzene rings. Okay, right? Now the next reactant that we have is formaldehyde. Okay, formaldehyde, it is an aldehyde, simplest aldehyde. Okay, HCHO. Then this undergoes condensation. Okay, condensation reaction in presence of H2SO4. Okay, and then we have a leuco compound. Okay, we have 2 benzene rings and the middle ring is a pyron ring. This is what we get. Now this leuco compound will undergo oxidation. Okay, what? Oxidation in presence of FeCl3, ferric chloride. Okay, and what we have here is this cunoid structure. Okay, cunoid structure. So what we see is this NMA group. It is being removed here. There is no NMA group here. Okay, it undergoes oxidation, right? And now you can simply break this double bond, or okay, these electrons can shift, undergo like resonance, or this is a cunoid form. Okay, and we have another form, simple form, right? So that's Pyronine G for you. ठीक है, क्या लिया? डाइमिथाइल अमीनोफेनॉल, फॉर्मेल्डिहाइड के साथ कंडेंसेशन किया, ल्यू को कंपाउंड मिला FeCl3 के साथ ऑक्सीडेशन. ठीक है, उससे हमें क्यूनॉइड फॉर्म मिला और फिर फाइनल डाई. नाउ what we have is fluorescein. Okay, this is very important. Now see, we have resorcinol. Okay, this is also resorcinol. What is a resorcinol? It is a metaphenol. Okay, disubstituted 1,3 disubstituted phenol. Okay, this is a water soluble phenol, very characteristic thing. Okay, it is some yellow brown flakes, and when you dissolve it the solution turns yellow. Okay, it might not feel like it would dry up to become something brownish, because I've worked with this, and this test you actually perform. Okay, this is not just a synthesis of dye, this test we actually perform in the lab. So this is phthalic anhydride. Okay, now how do you prepare phthalic anhydride? Oh, these are lab skills. Okay, how you do this in the lab. You take phthalic anhydride, okay, and you try to heat it. So what happens is it loses a water molecule, and phthalic anhydride it is collected on the sides of a test tube. Okay, this can also be formed in derivative formation, where you can actually obtain beautiful crystals in a funnel. Okay, so this is phthalic anhydride for you. These can undergo condensation with anhydrous oxalic acid at 150 degrees Celsius. Then 2 molecules of water are removed, and we have the benzenoid form C. These are 2 rings from resorcinol. Okay, and 1 OH group. We have this condensation happening here. Okay, from 2 OH, and again the lower part of the ring, the phthalic anhydride part comes from the phthalic anhydride. Okay, this is a benzenoid form. Okay, benzenoid form. What you can do is oxygen. Okay, it has lone pair of electrons. These can form a double bond, and there is a alternate bond shift. Okay, then we have a cunoid form. Okay, this thing, cunoid form. So this was fluorescein. So what happens is when you put it in dilute alkali, actually how this test is performed in the lab, here we are using anhydrous oxalic acid, but in the lab what you actually do is you add 1 or 2 drops of concentrated H2SO4. Okay, so first we take resorcinol, then we add phthalic anhydride, 1 or 2 drops of hydrochloric acid, we heat it, and we add this red substance. Okay, something red is formed. When you add that to a dilute solution of NaOH, there's a green fluorescence. Okay, very beautiful test. Okay, we'll just keep looking at it, and as always we'll just think about not discarding it. तो ये फ्लोरोसिन है, ये सिर्फ रिएक्शन सिंथेसिस नहीं है, इसका हम टेस्ट करते हैं. टेस्ट फॉर रिसोर्सिनॉल का भी कर सकते हैं और थैलिक एसिड का भी कर सकते हैं, थैलिक एनहाइड्रेट का भी कर सकते हैं, है ना. थैलिक एसिड की प्रेजेंस अगर हमें पता लगानी है तो उसको हीट करते हैं, थैलिक एनहाइड्रेट बन जाता है डेरिवेटिव, फिर उसको रिसोर्सिनॉल के साथ रिएक्ट कराते हैं, कंडेंस करते हैं, तो हमें फ्लोरोसिन डाई मिलती है. डाइल्यूट अल्कली में इट गिव्स फ्लोरोसेंस. ओके, द नेक्स्ट डाई इज Eosin dye. These are actually red. Okay, these can be yellow as well, but what we do is we have fluorescein dye. Okay, the one we previously prepared, पिछली slide में जो prepare किया था, what we do is we add bromine. Okay, bromination in glacial acetic acid. We have 4 bromine molecules, 4 bromine atoms. This is not a molecule. 4 bromine atoms are added, so it is tetra. Tetra means 4. Okay, tetrabromofluorescein. Okay, and this is a cunoid form. Now you can also convert this into benzenoid form. You know, oxygen, it has a lone pair, this will go towards the double bond, okay, this double bond, and then there's another bond shift, and the last one on oxygen, terminal oxygen, and it protonates, okay, then we have H. So this is a benzenide form, right? You can dye wool, silk as red, as you know. This is also the name of a cell, okay. Just go and find out eosinophil, something like that. I've forgotten a lot of biology, but anyway. So the last dye that we have in xanthene dyes is Mercurochrome. What we have here is dibromofluorescein, okay. This is controlled bromination. In the previous slide we have tetrabromofluorescein, here we have dibromofluorescein. So these syntheses are quite easy. Why? Because the basic structure is the same, okay. The xanthene ring, this is the main crux of this dye, okay. This part X, okay, this is the X factor of the xanthene dye, X factor. Let me just write it. No, mouse is still lagging a bit. So this is the X factor, okay. So this is all you need to remember. And the substituents, we have mercuric acetate, right? This is what we are trying to do, is we are trying to form a disodium salt of this part, the second product, or the first intermediate, okay. Let's say first intermediate, product would be a wrong word. So we have ACOHG added, okay. What is this? This is dibromohydroxy, okay, dibromohydroxy mercurofluorescein, okay. Write it down if you can. Then we react it with NaOH, we get the final disodium salt. As you can see, this is a cunoid form, okay, Q form, and it is known as mercurochrome. Disodium, see there is one sodium atom here, one is here, okay. And if you did not miss already, there's a bromine atom here as well, okay, so don't forget it. Right? Sometimes it happens. So I hope you understood what we are trying to do here, okay. We are going through synthesis, trying to explain as much as can, because there is a whole together different kind of boredom with reading from a book and having someone actually explain this to you. So what we have here is, first we discuss xanthene, okay. What is xanthene dye? Then Pyronine G, we have the synthesis, Fluorescein, right, the test that we perform in the lab, Eosin, okay. Fluorescein derivative, the last two ones are fluorescein derivatives only, okay. Then we have Mercurochrome. So I hope you understood these synthesis, and you can go through them again if you want to. That's all for this lecture. Thank you.